So we solved 2 by 2 matrices already with, 2 by 2 systems with matrices. Now we're going to look at 3 by 3s, but these ones will all be calculator questions. So remember the diagonal method for figuring out the determinant of a 3 by 3? And we also had the formula as well, but the diagonal method is easier to remember because the green arrows, those will all add up and you keep that as a positive number, and then the red arrows, you add those all up and you make that a negative, and then you add them up. So, find the determinant of this one. And I gave myself some hints where I should click to see the answer of certain things.
Oh, I can read it.
And I know I try new, sometimes I have these orange boxes where you click on them and then you see the answer, right? But I thought, ooh, these ones are like white. But I was afraid I would forget that I did that. So I put click to help me remember that I could click on that. Nice. But you can kind of see it, so I think I would remember. Anyway, so the blue arrows, take all those numbers, whatever you get, that stays as it is. The red arrows, whatever you get in there, you are going to subtract that. So in that red brackets, that adds up to 53. You take the 8 from the first brackets, the blue, and subtract the 53, and so we have a determinant of negative 45. Is this matrix singular or not? No, it is not singular because its determinant is not equal to 0. And what's important about the determinant not being equal to 0? It's not 0, right. So we can put a circle around it and not get confused. No, it means that the inverse exists. So I once put at the end, or was at the beginning of a test, I can't remember where I put it. The bonus on my test was on the bottom left-hand corner of page 2, make a smiley face and put a circle around it. Now, it wasn't supposed to be hard, but I had a whole bunch of people stressed out because they thought, is this a smiley face? And were you supposed to put a circle around it? Or is this a smiley face with a circle around it? And if I didn't put 2 circles around it, will I not get the bonus mark? I accepted both, but it caused the most stress whatsoever on that test. So I have not used that bonus question again. You think I should? Do you like that bonus question? I think. Yeah. So I don't know if anybody looked up the process yet online for figuring out the inverse of a 3 by 3. I think you get to use the transpose and everything. But we're not going to do that. All we're going to do is use our calculator. So put this one in. Well, you can't put this into your calculator. For this one, I want you to first figure out a value of x so the inverse doesn't exist. Multiply your diagonals one way. The blue ones are going to be your positive ones. Multiply your diagonals the other way. Those are the ones you're going to subtract. Set it equal to 0 to make it a singular matrix so the inverse doesn't exist. And then if you set up your equation, AP equals B, you could multiply both sides of that equation in front by A inverse. And that will get you that P would just equal A inverse B. So try to type that into your calculator And you know you've typed it in correctly if that is your answer. So now what we're going to do to solve our 3 by 3 system of equations is we're going to take our coefficients, make a coefficients matrix, and then create an answers matrix and a variables matrix, plug things into our calculator, and solve. So the nice thing about setting this up is you set up your matrices, then label them. Label this one's A, this is X, this is B, because then you can show all of your work with A's and X's and B's, and then just type in your answer from your calculator in the end. So in these questions, when you get your answer, if your answer, and these have nice numbers, 4, 1, -1, what you can do is you can plug those back into that equation that we had to start with. I will show you graphically what this is, because I think you'll find it interesting. So we solved that system of 3 equations and 3 unknowns. We got 4, 1, -1. And yeah,